Element 50 on the periodic table is 10. All right. So this is Norris Teaches Science with me, Mr. Norris. This physical science edition video. This video is in the physics section of physical science. It's also covering some wave information. I've done a couple of videos on waves. So if you haven't watched those, I would go watch those too. They really would help with understanding all the wave information. But today's topic is about wave interaction. So we're going to talk how waves interact with each other and how waves interact with barriers or surfaces, all this stuff. So by the end of the video, you should be able to say, I can describe how waves interact with each other and barriers. So what are wave interactions? It's how waves behave when they meet a surface or if they meet a barrier or they meet with another wave. And there's really four basic wave interaction types. We got reflection, refraction, diffraction, and interference. So we're going to talk about all four of those. First one we're going to talk about is reflection. Think about a mirror. You can bounce things off of it. Reflection is waves that bounce off or back from a surface. Now, for speed and frequency does not change when you have reflection. You just are changing the direction it's going. There's really two types of reflection. You have regular reflection and diffuse reflection. If you think of sonar or radar, that's kind of how it works. So let's talk about sonar. Okay, here's a boat. All right, and say there's a rock down here at the bottom of the ocean because sonar works in waters, and so the boat would send down sound waves, and it would hit the object, and it then would bounce back up to the boat, and the boat would look at the time difference between when it sends it down and when it comes back. It's able to form an image of the ocean bottom, and that's how sound waves work. Radar kind of works the same way, but radar uses radio waves and it sends it out, and it's usually good for. We usually use radar for like weather, while sonar is used for more when we're in the ocean or some body water. Fish finders use sonar as well. So the types of reflection, regular refraction, all the waves bounce off a surface at the same angle. So the surface is kind of flat and it's even, and so it forms a clear image. So this is like when you go look in a mirror and you can see your reflection, you looking back. That's regular reflection. Diffuse reflection is when waves scatter off a bumpy surface, meaning the surface isn't all smooth, and the image is hard to see. You get distorted images, like if you've ever been in a fun house, you can get the distorted image of yourself. Or say you're a guy, you're about to pick up your date, you're looking in your car door just to make sure that you look good. It's really hard to see exactly what you look like because the surface is bumpy, but you're still going to do it. Don't worry, you got this. All right, refraction. This is the bending of a wave as it enters a new medium. So you can see this in the picture. We have air and we have glass. The wave comes in at one angle, hits the new medium, and it's going in at a different angle. The direction never changes, so it's still going in the same direction. It just changes the wavelength and speed. And an example of this would be like waves coming ashore. Usually they come ashore at different angles. A pencil and a cup of water. If you've never done this, get a cup of water, a glass of water, stick a pencil in there, and you can see how it kind of bends. Light entering glass works the same way. Or you can look, say you're outside, you're fishing, there's a fish out there, and you're looking at the water at an angle, it would look like the fish is more closer to the surface than it really is in a clear body of water because of refraction. But if you look straight down at the fish, you're going to see the real position. I know people who they go bow fishing, and they actually have to remember they have to angle it down a little bit more so that they get the fish that they want. All right, diffraction. Diffraction is the bending of a wave as it moves around an obstacle or passes through a narrow opening. Ocean waves do this when they get to a barrier. This is also why you can hear a parade around the corner. This is also one of the reasons why light scatters in the sky, and it's one of the reasons why the sky is blue. So I have two examples here that we're going to draw with diffraction. This first one is a barrier in the middle of like a water body, and you're going to have waves come in like this. Waves are coming in. They're going to hit the body, the barrier, and they're going to go around the barrier, but you're going to have this empty spot behind the barrier. This is like breakwaters, and they have all these other things that in certain areas so that they can form little nice beaches behind it in coastal areas. Where I'm from, we have some of these, especially near the bay, so that the waves don't come in as hard from all the shipping lanes coming in. So you can have a beach back there and have a relaxing day. The other one, okay, we're going to have barriers, but there's going to be an opening in it. So we have waves coming in like this. They're going to come in. These waves are going to squeeze through this little opening. And when they come out, they're going to fan out. I kind of think this looks like a smiley face when I do it. But this is how diffraction would work if there's a little opening in the barriers. Next thing is called interference. Occurs when two waves overlap and combine together. And you can have destructive interference or constructive interference. Now, this picture down here is this ship was hit by a wave that was created by constructive interference. The sailors have a story of something called rogue waves that get really big and very destructive. So let's talk about constructive interference and destructive interference. Now, I'll pause real quick. Go get yourself 3 different colored pens. Get something paper down so you can draw out these examples. So constructive interference is when two waves move in the same direction and they collide and they produce a wave with a larger displacement. So we're going to have, first I'm going to use this blue color, and this is going to represent wave 1. So we have this first wave, it's coming in, it just kind of looks like this, and it's going in that direction. Then we get a second color, we're going to use green. This green, we're going to do a little scribble. This is going to represent wave 2. Wave 2 is moving a little faster than wave 1, but it looks kind of like this. It's going in the same direction as wave 1. Now, since wave 2 is moving faster than wave 1, at some point they're going to collide. So we're going to use red here, and this is going to represent the outcome wave, or the resulting wave. So what happens here, since they're going the same direction and they collide, they're going to combine together and they're going to create a bigger wave going the same direction. And that's kind of how constructive interference will work. All right, keep those colors aside. We're going to use them again. All right, so destructive interference is when two waves are moving in the opposite direction. And when they collide, they produce a wave that has a smaller displacement. So we're going to use the blue again to represent wave 1. All right, wave 1 is moving in this direction. It looks like this. Then we're going to switch over to green, and green's going to again be wave 2. Green is moving in the opposite direction. All right, it's going opposite. And remember, if you watch the displacement video, remember in the opposite directions they're going to subtract from each other with displacement. Same thing is going to work here if I can find my mouse. All right, so we're going to get red, and red's going to be the result wave. And so what happens here is that they're going to cancel each other out, but since one wave is bigger than the other, so you're going to get a smaller wave result. Sometimes they cancel each other out and you get that, where it just flats out and there's no more wave. This is how waves interact with each other in nature. I hope you learned a little bit about waves. Go learn up more, watch more videos, read up on it. But I'm Mr. Norris and I'm out for this video.